In this lesson we're going to deal with intersecting solids or interpenetrations. We're going to deal with simple setups that mainly deal with prisms. So I've got the front, the plan and the side view and first angle ready, apart for the curve of intersection between the two prisms. So basically what I have here is horizontal prism, a horizontal square prism, with a vertical prism connected to the top. Where the two meet is going to cause that line of intersection, and that's what I want to find, that line of intersection. Where would this corner end to meet to that point? So back to the orthographic views. In my front view is the only view that requires more work, that's incomplete, because this view is finished, there's no work done there, and this view is finished as well, nothing to add to that. So in a question like this, what you have to do is look at the prism. Generally is the smaller prism. The smaller prism, all its faces are in contact with the larger prism. So if you look at this cross section, that's the cross section of the larger prism. Now if you look at the cross section of the larger prism, only this corner is in contact with the smaller prism. Here, from here to here, this line here, this perimeter, is where the contact is between the two prisms. This corner, and this corner don't interest me much, because they're not part of the line of intersection where contact is made. But if you look at the smaller prism, this corner touches the bigger prism. So that's that corner which touches the bigger prism. All four corners are in contact with the larger prism. And I'm going to give it, each corner, a number, so I know which corner I'm referring to. So I just chose a number and went around like that. And what I want to do is, one by one, each corner projected into the front view. So I'm taking 1 and 3 projected into the front view. So 1 and 3 should be somewhere on that line. And then 1 and 3, I'm going to use the 45-degree line, which acts as if I'm reflecting the points, so point 1 onto the 45 degrees, which I had already prepared, the 45 degrees. I'm going to darken it a bit so that you can see it. So point 1 is projected onto the 45, taken onto the side view, and I found where point 1 is in the side view. Then I'm going to project it back to the front view so that intersects with the first line I projected in the front view. So point 1 is over there. So that's what I'm going to do basically with each point. I'm going to take two projection lines, one on the 45, on the line of intersection, which is this line, back into the front view, which intersects with the same line projected onto the front view. So the line went upwards like that, and it always forms that rectangle. So that's my first point. What I'm going to do is repeat these for the other points. So point 2 taken to the front view, taken onto the 45 degree, to the line of intersection, which is that point up here. Not here, I don't have intersection up here, I've got intersection up here, so that's point 2, and back to the front view. So follow the projection line from here, it goes around, and intersect the same point taken from here. So that's point 2. If I take point 4, that will follow the same point I've just did, goes over point 2, but it's on the other side. So if I take point 4 up here, that's my point 4, which goes round, and that's point 4. Point 3 will coincide with point 1, because since this is a symmetrical view, it's been placed symmetrically. Sorry about that. Point 3 will coincide with point 1. There. So point 3 is on the front side, point 1 is on the back side. I'm not saying that. But since it's a symmetrical view, you'll get no hidden detail, and point 1 is hidden behind point 3. So that's my line of intersection. So basically what we saw here is the method for finding lines of intersection. Numbering the smaller prism, taking each point onto the side view and project it back onto the view where I need the line of intersection that coincides with the same point projected upwards. Let's look at a different setup. Here I've got, this time I've placed the prism upright, but the smaller prism now is offset. It's not symmetrical, it's offset, it's placed to the side. So what I've got, let me try to draw this, give you a sketch. I've got an upright prism, and then I've got a square prism that's connecting to the larger prism, but not centrally. It's been offset a bit. So this corner is interfering with my line of intersection. Now that's a very important corner where I'm interfering. Hope that sketch didn't confuse you even more. So again, I'm looking at the smaller prism, which is this, in this view. The curve of intersection is required here. And I'm going to number the corners I need. But I have to make sure that now I'm numbering also the 2 points that are interfering between the two sides. So this edge here is interfering these two sides. So when I'm numbering not only the edges, but I'm numbering those interfering points. So I've got 6 points I need to find, not 4, because the corner of the larger prism has interfered through the sides. But then again, it's the same method. Taking point 1, projected onto the front view, and taking point 1 down to the 45 degrees, it hits the point of the line of contact. This is my line of contact. It hits my line of contact there, and when taken vertically up back to the front view, I've got my point 1 over there. So I've closed the rectangle from here, going projected to the 45, hitting the line of contact back into the front view, and that projection line hits there. Point 2 has been projected already down to the 45. This is point 2, back to the front view. That's my point 2. Point 3, same thing. Projected to the front view, to the 45, the line of intersection there. So this is what I'm going to see from the front. I'm just going to connect point 1 to point 2, point 2 to point 3. Now if you're not required to show any hidden detail, that would be ready. But fortunately, a question like this, most often than not, would require hidden detail. Why? Because it's offset, and point 5 is not going to coincide behind point 2. So let's keep on going. Point 4 and 6. Point 4 and 6, I know already that they're on this edge, which is this corner here. So this corner, this edge here, is this corner there. So I'm going to do the same thing with point 4 and 6. I'm going to project them both at the same time. So that's point 4, that's point 6. When projected onto the plan using the 45, you'll get this corner here. When projected up, vertically up, you get point 4 there, there's point 6 there. I've got my final point, which is point 5. So following point 5, projected down onto that point there, projected upwards, there's my point 5, which is in projection with this line. So continuing the number 1, 2, 3, the first point I did, 1, 2, 3. This is point 4. This is point 6. And back to point 1. So that gives you a rather strange shape when compared to the previous one, which is a symmetrical shape. But you have to realize that this edge here has been derived because I've had a corner on which I had to go around, which is this corner here. So it goes around that corner to get that. To make it complete, I'm going to add a hidden line there to show where the perforation in the bigger prism has been achieved. So those are two basic shapes. One has been centrally placed, the other offset. Let's go to another example. I'm going to deal with cylinders now. Same thing, just slightly more work, because the cylinder, curved surface edges, curved surface area, and you've got no edges to work on. So, as we always do when we're dealing with circles, we need to invent some lines to work with. So the circle, not this circle, because most of that circle I'm not going to use. I'm just going to use this part of the circle. So look at the smaller circle, the smaller prism, and all of that prism is in contact with the larger prism, with the larger cylinder. So I'm going to divide my circle into 12 parts. Number each one of them. And each one is going to be projected onto the 45 degrees, onto the line of contact, which is from here to here, and back into the front view. So I'll find the curve of intersection. So it's just the same work, but using more points. So point 1 projected horizontally, projected vertically, onto the 45, back to the plane, and goes back into the front view. So that's point 1. Point 7 would be on the same line, but down here. So this is point 2 and 12, but since it's a symmetrical setup, point 12 will be behind point 2, and you're not going to see any ND there. Back into the front view. So each point will produce that rectangle projected both horizontally and vertically, hits the 45, hits the line of contact, and back to hit the projection line produced horizontally. So those are my first 2 points. A third point to the 45, back to the line of contact, back to the front view. Once I do number 4, I'll be halfway done. That's number 4. So far my curve of intersection is this. Notice that now I've produced a curve instead of a straight line, since I've got a curved surface area. So what I need to do to continue this is just continue 5, 6 and 7 as I did on the top, and I'll get the symmetrical shape I had on the top. There. If the 2 cylinders were of the same diameter, the curve of intersection, instead of being a curve, you'll get a 45-degree line. So the points of intersection will be in a straight line that produce 45-degree like that, 45-degree line. That's if the 2 circles are of the same diameter. Let's look at this setup. This setup, we've got 1 cylinder, 1 hexagon. So what I'm going to start off with, this is the view I need. We've got the smaller prism. I can see its section. I can see its cross section. I'm going to number each point. I'm going to take each of those points onto the front view, the same as I did before. As I do that, so point 1 and point 3 are on the same line, 1 and 3 are on the same line. They hit here after they hit the 45-degree line, and I'm going to take them back up to get 3 and 1. Because 3 and 1 were projected also horizontally. Point 2 is this point here. Point 2, it hits this point, projected up. Point 2 is there. So the 3 major points I found 1, 2, 3. If I want to find 4, 5, 6, they would coincide with 1, 2, 3. So 6 would fall under 1, 5 would fall under 3, 4 would fall under 3. But this hasn't finished yet, because here in this setup, where I've got a cylinder, a vertical cylinder, intersecting a hexagonal prism, the line between the cylinder and the prism is not going to be a straight line, it's going to be a curve. So I need extra points to get that curve. Now how am I going to get those extra points? So I'm going to look at the side, and I'm going to take the midpoint of point 1 and 2, the midpoint of 2 and 3, the midpoint of each side, and use those extra points to produce a curve. Now depending on the size of your prism, it will determine how many points to take. I'm just taking one point between 1 and 2, and between 2 and 3. You could take any point, but taking the midpoint would be more convenient. So this is the point between 1 and 2, this is the point between 2 and 3, projected onto the 45 degree, onto the line of intersection, so you can't see that. Onto the line of intersection and back into the front view. So these 2 points have produced an extra point here and here, which will help me draw the curve. And another point here that helps me with the drag curve. In this case, since it's centrally placed, also I don't need hidden detail because they're going to be hidden on the actual view line. So again, it's the same method, just a bit more work finding these extra points onto the line of intersection and back where they hit the line. Now these questions could be so diverse, you could change them around so much that it's possible to get each and every question in. But just look at the last question here. Where I've got an octagonal prism with a vertical square prism. Again, taking not only the 4 points of the prism but also the other 4 points of the octagon. So these 2 corners must be taken into consideration as well. So each point is taken onto the octagon, onto the 45, to the octagon and back into the front view, and then intersecting with the point you need to find. I'll skip this part. From this sketch you can realize that this part has hit a flat surface, so you're going to get that edge which will cause this flat surface, and that's where it's hitting the flat surface, and only this part reaches onto the diagonal face, this. And what I did was just simply point 2 taken onto the 45 to that corner, back to where point 2 coincides with the vertical projection line. That's why I do some numbering, so I know how to connect each dot. Alright, so those are your basic intersecting solids to find the lines of intersection.